Hello and welcome to your first online lab. This is kind of weird because it's all those videos that you have to look at. What I recommend is before watching these videos, go through the PowerPoint and also the lab itself. These videos can talk about how the data is collected. They won't necessarily talk about how to analyze the data. That you'll find in the PowerPoint and stuff. If you were in person and life was good, you'd be doing these bits yourself that's in the video. Today's lab is actually especially weird because we haven't covered any actual physics yet. We've just talked about science in general. But today's lab, its point is to teach you how to make a graph and how to analyze data and how to do unit conversions. It's a lab about all three of those things. There's also a bit for practice for algebra and the post-lab questions. I guess I want to talk about those now real fast. The post-lab questions are a series of math problems asking you to rearrange problems. Feel free to get help. You don't need to do those on your own. Every one of those problems is the type of math you can expect to see in this class. I don't expect you all to be able to solve all of them. Honestly, number 6 is really hard, and number 6 is really hard, and I don't expect many of you to be able to get it on your own. Get help, work with each other, do whatever you need to do. I will have my office hours, but I just want you to be aware of the math this class has coming in. Now, for the actual lab today, we're going to look at the ideal gas law, which is something I admittedly haven't taught yet. I haven't really taught anything yet, but as I said, it involves a lot of unit conversions. And the ideal gas law is as follows. PV equals NK sub BT. You might be familiar with it in a different form. That's because chemists use it differently. In this equation, P is the pressure of the gas, which must be measured in newtons per meter squared. V is the volume of the gas, which must be measured in meters cubed. N is the number of atoms of gas. K sub B is a constant, as you can see written beneath it. And T is the temperature, which must be in Kelvin. We're going to go mess around with pressure, volume, and temperature using this chamber here. And what I'm going to do is I'm going to close this chamber so no air can escape, and I will start messing around with the volume by turning this crank. And as I change the volume, we're going to see how that affects the temperature and pressure. Now let's zoom in a bit today. Now in some labs, I will give you the data. Some I expect you to get the data from the video. Today will be a data from the video day. Now what we have here is this would be your volume. This volume is measured in milliliters. But keep in mind, 1 milliliter is 1 centimeter cubed. So that'll be your volume in centimeters cubed. This is your relative pressure, aka pressure above atmospheric, which is measured in newtons per centimeter squared. And this would be your temperature in Celsius. Now, first off, we can't work with relative pressure. We need absolute pressure. So whatever value you get here, you're going to have to convert it to absolute pressure, which is not really a set unit conversion. Just use equation 5. Basically, you're going to add 10.13 to everything. But once you have this absolute pressure in newtons per centimeter squared, I want you to convert it from newtons to centimeter squared to newtons per meter squared. Keep in mind that's not a simple conversion of centimeters to meters, but 1 over centimeter squared to 1 over meter squared. Also, this volume in centimeters cubed, you need to convert that to meters cubed. And this temperature in Celsius, you need to convert that to Kelvin. But that's also a weird unit conversion. Use equation 4 for that. See, what I'm going to do is I am going to, right now, starting at this value, I would like you to record the volume, which in this case is 65 centimeters cubed, the relative pressure, 0, and the temperature, 29.5 degrees Celsius. And once you record those, I'm going to start changing the volume. As I decrease the volume, I'm now at 55 centimeters cubed, and I want you to record the new pressure and the new temperature. You note the temperature is going to start changing, start dropping. You kind of want to take it, I would recommend pausing once I get to a thing, because it's going to start equalizing with the temperature. You want to get the temperature right when I stop moving. We'll now go to 45 centimeters cubed. And record the pressure and the temperature. And feel free to pause, obviously. Sorry. Record the pressure and temperature. And we'll do 25 as our last one. Record the temperature and pressure. Okay, you're going to use those values, and once you have those values, do all your unit conversions, and we're going to try making a graph. How to make a graph, I'm going to have a separate thing on. We've also talked about it in class, but you can find that there. Please come get help as needed. That's what my office hours are for. Otherwise, good luck.